Welcome back, MathLovers. Today I'm going to introduce you to one of the important and interesting rules of differentiation, so-called product rule. Everyone who had called crossed calculus in their life, they would know this particular rule like memorized in their fingertips, but not really its meaning or what is the real purpose. So I'm going to show you. Consider you have a rectangle of a certain length and a certain breadth, but not a fixed one. So both L and B are functions in X. Let's say they are both functions in X, meaning, for example, I'll keep length of the rectangle as X plus or like X square plus 2X, and breadth of the rectangle as 2X, like that. So now if we introduce a very small change in the length, if we introduce a very small change in the length, okay, so this will be considered as small change in length. So we'll call it as del L. We'll call it as del L, or just for not for you not to get confused, I'll call this a small change in L, like this, del L. Similarly, if you introduce a small change in the breadth, you would be calling it as del B, that small change. Now what we are seeing here is a bigger rectangle. What you are seeing here is a bigger rectangle. So what was the original area? The original area was L into B. Now what is the new area? The new area is L plus del L multiplied by B plus del B. Okay. So if you expand this, you'll get LB plus L times del B plus B times del L plus del L into del B. Okay. So now with respect to this, you can see actually this is a rectangle here. This portion is a increase in that area, creating B into del L. And this portion is also an increase in area, which is actually created by L into del B. And this is created as a small portion here, which is del L into del B. So what is the change in area? If we subtract the new area minus old area, you will get the change in area. New area minus old area, when we subtract, we will get the change in area. So new area, I have got it as LB plus L times del B plus B times del L plus del L into del B. From this, you are actually subtracting this old area L into B. So plus LB minus LB gets cancelled off. So we are left out with this. Since in differentiation thought, we consider this del L or del B and all as very, very insignificant change, we can ignore. This term will be insignificant. We can just ignore that presence. So then we finally get L times del B plus B times del L. Since I have mentioned at the starting itself, both length and breadth are considered as functions in X. So here we understand when I'm differentiating such a thing, L into B, which is the product I'm differentiating, and both are in terms or functions of X. So with respect to X, then we understood what result we are getting. We are getting L times del B, which I can write as dB by dx, because the change is done with respect to X only, plus B times del L, which can be written as dl by dx. Hope you now understand what is really the meaning of product rule in the real aspects, not just as a formula. Hope you enjoyed this video. We'll meet in another interesting process.